Humans have a very specific relationship with milk. For most of our ancestors, drinking a glass of raw milk was essentially a biological gamble with an immediate and violent payout of stomach cramps and digestive chaos. Yet we domesticated animals for milk. This is a paradox. We spent thousands of years wanting a resource that our bodies literally rejected. The solution wasn't a medical breakthrough. It was a series of happy accidents involving bacteria and animal organs. Today, we are going to look at the biological hack that allowed humans to unlock the nutrients of the animal kingdom without the accompanying gastrointestinal disaster. Imagine the Fertile Crescent around 8000 BC. The air is thick with the smell of dry dust and the heavy scent of livestock. There are no supermarkets, no refrigerators, and certainly no pasteurization. There are only clay pots, hand-molded from river mud and fired in open pits. These pots are coarse and porous. They aren't just containers. They are tiny, unplanned laboratories. The tactile reality of the Neolithic era was essentially a constant struggle against spoilage, where the difference between a meal and a poison was often just a few hours of sunlight. Meet our Neolithic farmer. He isn't a hero of history. He is just a man who is very tired and very bloated. He knows that the liquid from the goat is nutritious, but he also knows that drinking it leads to a day spent in a very uncomfortable position in the dirt. He exists in a state of constant biological frustration. He wants the calories, but his DNA is telling him that milk is an enemy. This is the baseline of the human experience for millennia. A desire for sustenance fighting against a digestive system that is fundamentally not designed for it. Then comes the first accident. Our farmer leaves a clay pot of milk out in the hot sun. He forgets about it. Now, usually, leaving food in the heat results in rot. However, in this specific case, the porous clay pot traps wild bacteria from the air. These bacteria begin to feast on the lactose, the milk sugar, converting it into lactic acid. This acid changes the pH of the liquid. As the environment becomes more acidic, the proteins in the milk begin to clump together. The milk was left in the sun, therefore the bacteria moved in, but instead of becoming a toxic sludge, it transformed into a thick, sour curd. It didn't rot, it organized. Now, we have to consider the mental state of a person who finds a clump of sour, semi-solid milk and thinks, yes, I should put that in my mouth. From a modern perspective, this is a health code violation. From a Neolithic perspective, it was a survival strategy. The curd was more concentrated than the milk. It tasted sharp, it felt substantial, and most importantly, it didn't cause the same violent reaction in the gut. The farmer discovered that by letting the bacteria do the work, the lactose, the part that caused the pain, was largely gone. He had found a way to eat the milk without the milk fighting back. But there is a second, more visceral path to discovery. There is a popular legend about a nomad who carried milk in a pouch made from a calf's stomach. He tied it to his donkey and rode across the desert. By the time he arrived at his destination, the milk had turned into a solid mass. While the story is a bit romanticized, the biological reality is genuine. Inside the stomach of a young ruminant, like a calf or a kid, there is a complex biological machinery designed to do exactly this. Calves need to digest milk efficiently, so their stomachs produce an enzyme called rennet. We don't have to rely on legends because the dirt remembers. Archaeologists have found perforated pottery and primitive sieves in Poland and Turkey dating back to the early Neolithic. These aren't just fancy bowls, they are tools designed to strain curds from whey. A hole in a pot is a simple thing, but in 6000 BC, it was a high-tech invention. It marks the moment where cheese stopped being a weird accident and started being a deliberate industry. Humans realized that if they could mimic the stomach of a calf, they could create a stable food source that lasted for months. To understand how this actually works, we have to look at the abomasum, the fourth stomach of a ruminant. This is where the magic, or rather the chemistry, happens. The abomasum secretes chymosin, the primary enzyme in rennet. Chymosin doesn't just stir the milk, it performs a precise molecular surgery. It cleaves a specific part of the kappa-casein protein molecules. Normally, these proteins repel each other, keeping the milk liquid. Once the chymosin cuts them, the proteins stop repelling and start sticking together, forming a structural network that traps the fat in water. It is a microscopic construction project that turns a beverage into a building block. There is something deeply absurd about the fact that one of the world's most sophisticated culinary traditions began with people essentially eating the processed contents of a stomach. We spent centuries refining the art of the brie and the roquefort, but at its core, cheese is just a simulation of what happens inside a baby cow. We are eating a biological byproduct of a ruminant's digestive process and calling it a delicacy. It is a testament to human desperation that we looked at a stomach lining and thought, this is the secret to a great snack. This discovery didn't just change the menu, it changed our DNA. For thousands of years, humans were lactose intolerant, but because we had cheese and yogurt, where the lactose was already broken down, we could survive and thrive on dairy. This created a massive evolutionary pressure. Those who had a genetic mutation that allowed them to digest raw milk, known as lactase persistence, had a significant survival advantage. By roughly 5500 BC, this mutation began to spread. We didn't evolve to drink milk, we evolved because we found a way to cheat the system with cheese first. We will never know the exact moment of the first taste. We don't know if it was a forgotten pot in the sun or a leather pouch on a dusty road. We only know that someone, somewhere, looked at a spoiled liquid and decided to risk it. There is a certain bravery, or perhaps a profound lack of options, in the first person who tasted a clump of sour milk and decided it was a victory. It is the ultimate example of how human progress is often just a series of mistakes that we decided to keep. From a liquid that caused biological warfare in the gut to a global obsession, the journey of cheese is a journey of adaptation. We moved from the porous clay pots of the Fertile Crescent to the sophisticated laboratories of modern dairies, but the chemistry remains the same. It still relies on the abomasum, the chymosin enzyme, and the simple act of clotting proteins. The most ironic part of this entire history is that rennet, the substance that makes almost all hard cheeses possible, is derived from the stomach lining of an unborn calf. Our modern gourmet obsession with a complex cheese board is, in reality, a celebration of Neolithic stomach cramps and the biological machinery of a baby cow's digestive tract. It is a very fancy way of remembering that we once couldn't handle a glass of milk. Aftermath legacy explicitly linked cheese consumption to the genetic mutation of lactase persistence. Closing synthesized concrete facts, abomasum, 5500 BC, rennet source, into a final ironic observation. Word count, 1520. Duration estimate, 10.5 minutes.